All right, starting chapter 3 today. Part of what you've got to know is things you learned in the past to do chapter 3. You got to learn how to plot a point. And remember, you got your x-axis is your horizontal axis, y-axis is your vertical axis. Hang on, I got to sneeze. Oh, excuse me. So when they give you an ordered pair, the first coordinate on what we're graphing is going to be the x. The second is the y. The x, that runs horizontally. The y runs vertically. Positives to the right, negatives to the left. Positives up, negatives down. So if it says, go plot the point 3, 2. I'm going to go 3 places to the right and up 2. And I'm going to call that point A. Okay, negative 5, 1. I go 1, 2, 3, 4, 5 to the left and up 1. We'll call that B. Over 0, up 3 is C. Back 1, down 4 is D. 3 to the left and stay put. Don't go up and down any. That's E. And then over 2, down 1. That's F. All right. And then also to refer to where you are, let me get this a different color. People call the 4 sections of a graph, we call those quadrants. This is quadrant 1, quadrant 2, quadrant 3. For some reason, I really don't know the answer to this. It's always given in Roman numerals. Don't really know why. But here's quadrant 4. 4 in Roman numerals is an IV because it's 1 less than 5 and V is 5. So, and if you're on one of the axes, you don't say you're in a quadrant. Okay. Also, to be able to work this chapter, we've got to be able to plug numbers in. So this is just evaluate 4 times whatever x is minus 5, but let x be 3. That's all we're doing. So do negative 2 times whatever x is plus 9, but let x be negative 9. So we multiply first. There's 27. Okay, so that's just some prerequisites for us to do this chapter. You have to be able to easily do those things on this page. I think pretty much most of y'all can do that. Okay? All right, so then we're going to start out with chapter 3. First, we're going to start talking about a relation. And it pairs inputs with outputs. And that could be anything. Like, say I told you that x squared plus y squared was 9. And then you let x be 0. Okay, well, 0 squared plus what squared makes 9? I could put a 3 in there. That's a relation. Like, I just related the two. X had something to do with y. And it doesn't have to just be numbers. Like, it might be, like, the relation might be name a state and then name its population. Like, those have something to do with each other. Okay. When you name a relation as an ordered pair, you put the inputs as your x's, outputs as y's. So inputs, output. You plug a number in, you get a number out. A relation that pairs each input with exactly one output, that's called a function. So that would be something like up here, the one I gave you, that's not a function because I could have also plugged a 0 in for x. And it's true if I plug a negative 3 in for y. So that's this one input went to 2 different outputs. But if it goes to only one output, it's a function. So it's kind of like making up a multiple choice test. A, B, B, D. So that's the answers. Like for every question, that's your input. The answer is your output. You want, for every question number, you want there to only be one answer. You know, it's kind of a bad multiple choice test if the answer to number 1 is either A or B. You know, but it's okay to have the same answer. Like you're not going to take a 20-question test with 3 to 5 choices and only have A one time probably. So it's kind of, I'll refer back to that a lot. Like, yes, it's like your test. You want one answer. So you can describe functions in lots of ways. Like here's a graph. So here's an example. They're saying if 0 is my input, 8 is my output. If 1 is my input, 6 is my output. So like I could do these as ordered pairs. I plugged in a 0, I got out an 8. I plugged in a 1, I got out a 6. I plugged in a 2, I got out a 4. I plugged in a 3, I got out a 2. I plugged in a 4, I got out a 0. Inputs, outputs, X's, Y's. You can do that with a mapping. That's where you say, okay, here's my inputs, here's my outputs. 0, 1, 2, 3, 4, and then you show what they go to. 0 went to 8, 1 went to 6, 2 went to 4, 3 went to 2, 4 went to 0. That's a mapping. You can just talk about it in words. Like if we look over here at the graph or at the mapping, I could say that, what could I say? Like for every increase of 1 on the X, the Y decreased by 2. Where the first, like you can talk about it lots of ways. We could come up with a rule for it. You could do an input-output table or a T-chart. Like I could say, here's X's and Y's, 0, 8, 1, 6, 2, 4. Or a lot of times our textbook will write it vertically and they'll say input, output. And so you plugged in a 0, they got out an 8. They plugged in a 1, they got out a 6. Now, for the equation, we'll work our way up to that. I can go ahead and tell you what it is. It's that. So that for every X I plug in, I multiply by -2 and add 8. So I plugged in a 0, I got out an 8. I plugged in a 1, I got out a 6. So there's lots of ways of describing functions. Most of this section is just going to be, can you tell if it's a function or not? So remember, for every X, I want 1 and only 1 Y. X is 0, gets out 8. Okay, look and see all the other X's. Is there ever another X is 0? Okay, well, that looks good. X is 1, you get out 8. For every X, I got only 1 Y. I plugged in 1 in and got anything else. For X being 2, I got out an 8. For X being 3, I got out an 8. For X being 4, I got out an 8. That's like our multiple choice test where all the answers are A's. Totally okay. You got answers. Okay, so is that a function? Yes, because for every input, there was only one output. Now here, though, they plugged in an 8, got out a 0, and a 1, and a 2, and a 3, and a 4. That'd be like question number 8 had 5 answers. Yeah, that's not okay. This is not a function. Okay, so answer this question. Does it represent a function? Yes or no? This one, is it a function? No, because 3 messes it up. That X, that input went to 2 outputs. Not a function. This one, plugged in 0, got out 8. Plugged in 1, got out 6. Plugged in 2, got out 4. Plugged in 3, got out 2. 4, got out 2. Ooh, here we go. 5 is messing me up because I'm getting out both 4 and 5. Not a function. And right there, also messed it up. When I plugged in 7, I got out 2 different outputs. Sometimes they'll write them as ordered pairs. So you're looking, all right, -2 got out a 5. Did -2 ever get out anything else? No. -1 got out an 8. Did -1 ever, see how the X's are different? That's a function. Every X went to 1 and only 1 Y. But let's see, -2 should get out 0. Okay, don't see another -2. -1 should get out 0. Oh, but it also got out 1. Not a function. Okay, sometimes they'll do words. Each radio frequency X in the listening area has exactly 1 radio station. Like when you turn the radio on, it says 98.7, it's going to go to that 1 station. It'd be a big old mess if it went to try to get 2. So this is a function. But the same television station, X, can be found on more than 1 channel Y. So it's like, say you're looking for ABC, the local ABC affiliate. We just moved here. I don't know what that is. But say it's on, that's what your input is. But it's on channel 4, and it's on channel 7, and it's on channel 9. That's not a function. Okay? All right, X being 2. Sometimes it's an equation. But it doesn't say anything about Y. I mean, Y could be anything. X could be 2 and Y could be 12. X could be 2. It could be -435. Not a function. Okay? But this one, think about it. If you plug numbers into that. Say I plug a 0 in. I'm going to get a 3 out. I can't get anything else because I'm going to plug that in there and it's only going to give me the one answer. Okay. And then on part D of example 4, can you see how this thing called a vertical line test helps us determine whether or not the relation represents a function? Okay, so back right here. There's something called a vertical line test for functions, where if I just draw a vertical line and it touches more than one output, that means it's not a function, which makes sense because for every x, I want it to only go to one place. Like every other vertical line only touched one because you only had the one output. This one you had 2. So that's a big thing we're learning today, the vertical line test. So a graph represents a function when no vertical line passes through the graph more than one time. So we're going to use that as we go through here. So here's some examples for you to try. Determine whether the relation is a function. Be prepared to explain why. Okay, -1 goes to 4, 3 goes to 15, 11 goes to 15. Doesn't matter, they go the same answer. Each input went to one and only one output. That's a function. But a half goes 3 different places. Not a function. Okay, look at all these x's. Are they all different? Oh, okay, 0 may mess me up. Yep, does. It goes to 2 different outputs. Not a function. 2, 4, 6, all the inputs are different. They're going to go somewhere. It's a function. Okay, so when it's a graph, we're going to do the vertical line test. That looks like a function. Oh, not a function. 1x gave me 2 y's. This one, if I draw vertical lines, it's only going to touch one time. That's a function. Oh, I skipped those ordered pairs. Ooh, sorry. Here's the, oh, I left a parenthesis off. Dang it. Right there, 5 goes to both 0 and 10. Not a function. Let's see on this one. All those x's are different. Function. I need to go back and fix that one thing. All right, so, and then I think this is the last part for today. Yeah, last thing for today is talking domains and ranges. Domains are the inputs, ranges are the outputs. For what we're doing, domains are x's, ranges are y's. It's like you plug a number in, a function does some work on it and shoots a number out. So they're going to ask you to tell the domain and range of each of these, represented by each of these graphs. And we can use D for domain, R for range. Domains are x's. You just you squish the points to the x-axis. Like this point, look at its x. Look at its x. That's already on its x. So I'm looking here, 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 and here. So the domain of this function is -3, -1, 1, and 3. Those are the x's that I'm talking about. Those are my inputs. When it wants the ranges, squish those points to the y-axis. So -2, 0, 2, 4. So it's just a set of points. Now, our textbook doesn't put the set markers around it, but pretty much every other textbook under the sun does. All right, so part B, we're going to do the same thing. We're going to squish all these points to the x-axis. Like just shove them down there. See how it would cover from here to here? So my domain, it's the set of all x's where -2 is less than or equal to all those x's, which are less than or equal to 3. And when I do the ranges, I squish all the points to the y-axis, and it'll cover all the way from here to here. So it'd go from -1 up to 2. Okay, this one, domain, look at your x's. -2, -1, 0, 1, 2. My ranges, push them to the y. Those 3 points right there. 0, 2, and 4. Squish them to the x. It's going to cover from there to there. So domain is 1 to 5. Range. Squish all these points to the y-axis. It's going to completely cover from 0 to 4. All right, that's her notes.